So let's do one more of these. Let's now see what happens when we try and rotate around a different axis. We're going to take this region of the graph of y equals x cubed and rotate it around the y-axis. Now, because we're rotating around the y-axis this time, we're not drawing a strip like this perpendicular to the x-axis as we've done the other times. Because we're rotating around the y-axis, our disk is going to have this as its radius. So since this strip is rotating around the y-axis, we do have to kind of twist our heads a little bit to figure out what we do with this, but not too much. So our disk now is going to look a little bit like this. So our cross-sectional area is going to be pi r squared again, but this time the r is going to be an x value. So this is really pi x squared. And so our volume for this disk, the volume of the disk is going to be pi x squared times dy, because that's the thickness of this disk now. So dy, that tells us that we're integrating with respect to y. We have to do something in order to get our function in terms of x. So let's take the fact that y equals x cubed and solve for x. X is equal to y to the 1/3, just using some of our inverse operations. So that means that our disk volume is going to be pi times y to the 1/3 squared dy. And so our total volume, now that we have the volume of our little piece, this is a simple step forward. The total volume is going to be the integral from y equals 0, which is here, to this value up here, y equals 8, of this quantity. So times pi y to the 2/3 dy. We can evaluate that real nicely. This now becomes 3/5 pi times y to the 5/3. We're evaluating this from 0 to 8. That 0 doesn't really give us anything, so this results in 3/5 times pi times 8. The cube root of 8 is 2. 2 to the 5th is 32. So our final answer there will be 96/5 pi, and then units cubed, whatever our units happen to be.